Hello students, welcome to Excel Education Center. Today we are here for the revision series of electricity chapter from grade 10th. I believe by now most of you have already revised the basic formulas of the chapter, and using the same we'll be going through some really important problems that you need to learn and go through before your final board exams. Now let's directly dig into it. Let's go for the first question and see what we are asked here. Now given to you is that assuming that the charge on an electron is 1.6 into 10 to power minus 19 coulomb, even if they are not giving it to you, we should remember it, right? So sir, the charge on the electron is given, which we denote it as small e. So sir, the charge on the electron is 1.6 into 10 to power minus 19 coulomb. Now don't be worried about the sign, right? That's sir, it should be negative, because in the formula you can easily adjust accordingly. Moving on, that sir, they are saying the number of electrons passing through the cross-sectional area per second. So time given to you is 1 second here. Easy. Sir, they are saying when the wire carries a current of 1 ampere. Now everyone, please write down the given data. That should be the first step of dealing with any problem that you have in current electricity. Now, when I look at this, they are asking me the number of electrons that are passing through the cross-sectional area, and as far as I remember, sir, we denote the number of electrons with N. Now, try to recall the formula for current. I believe most of you remember the first formula, that sir, current is rate of flow of charge. Rate of flow of charge? Yes. Sir, we used to write that I is equal to Q by T. But the charge that you talk about, that is formed because of the small electrons. So sir, how many electrons are passing through a particular wire in 1 second? The total charge that they carry through the cross section in 1 second, that is what my current is. Now obviously sir, the electrons, each electron carry a certain amount of charge, which is equal to 1.6 into 10 to power minus 19. If we know the charge, now we have to find out the number of electrons that are passing through this cross section in 1 second. Sir, I is equal to Q by T, and the total charge that passes through this, if I say the number of electrons that are passing are N, so total charge will be what? Number of electrons into the charge on 1 electron. Number of electrons into the charge on 1 electron. So the formula, which is I is equal to Q by T, can be written as Ne by T. Now sir, if I look at the entire dynamics of this formula, current is given to me. Yes. Number of electrons is what I am looking for. Yes. Sir, E is 1.6 into 10 to power minus 19, and time is 1 second. Now when you substitute this, then you just need to rearrange the entire formula, and you will get N is equal to 1 divided by 1.6 into 10 to power minus 19. Sir, what to do next? My friend, always if you have 10 to power something, make sure you take it to the numerator. Sir, but if I take it to the numerator, the power which is negative will turn into positive. So what will I get? Sir, N will be equal to 1 divided by 1.6 into 10 to the power 19. Now my dear students, basically you have a division here, 1 divided by 1.6. If you try to solve it, you can write it down as 10 by 16 as well. But my suggestion is remember this result, because this is a very standard result that every student should remember, that 1 by 1.6 is equal to how much? 0.625 into 10 to the power 19. Sir, if I basically take this to this side, 1 10 I involve with 0.625. Take 1 10 out of this 19 and multiply. Sir, I will get 6.25 into 10 to the power 18 electrons. So my dear students, remember this. This is a standard result and every one of you should learn it by now and should learn it from now onwards. If you are ever asked that sir, 1 coulomb of charge has how many number of electrons, please remember that sir, 1 coulomb of charge is equal to 6.25 into 10 to power 18 electrons. By combining these many electrons, my friend, we make 1 coulomb of charge. But you will be thinking, oh sir, but here they were not talking about charge, they wanted 1 ampere of current. But my friend, can I say, if your current is 1 ampere, your time is 1 second, sir, Q is equal to what? 1, because Q is equal to IT, and sir, 1 into 1 is 1 coulomb. So if someone already remembers the result that 1 coulomb is equal to, sir, 6.25 into 10 to power 18 electrons, so please make sure you directly can mark the answer 6.25 into 10 to power 18. I hope the concept and the bullet point from this question, what we have learned, is very clear to everyone who is doing these questions. And my suggestion to all the students is, before I discuss the question, pause the video for once and try it yourself. Let's see if you can reach the final correct answer. If not, obviously you can play the video anytime and you can watch it out. Right? Moving on to the next question. So please remember this result, which is very, very important from this question that we learned, that 1 coulomb is equal to, sir, 6.25 into 10 to power 18 electrons. Moving on. The second question says, let's read the question first and then we'll go to the solutions. Everyone can pause it, try it, and then obviously you can play for the solution. A wire of resistance R is cut into n equal parts. These parts are then connected in parallel. The equivalent resistance of the combination will be. Again, a very standard question, which every one of you guys need to remember it. If not, let's dig into the primary solution of this. Sir, how do we do this? You have a resistance R wire. Yes, sir. They said the resistance of the wire is what? R. This R is cut into n equal parts. Sir, how many? N equal parts. Now please remember one thing. If you cut a wire into n equal parts, equal how? Equal length, right? And sir, someone wise told me that resistance is directly proportional to length. Yes. So that means if I cut this into n equal parts, sir, each of the piece will have a length 1 by n times. So that means the resistance of each part will also become R by N, R by N, R by N. Sir, how many R by N? N number of R by N. How many N? N number of R by N small pieces of wire you have with you. What are they saying? That they are connected in parallel, Sirji. If they are connected in parallel, they are asking to find out the equivalent resistance. Let's go to the basic formula that told me that 1 by Rp, the resistance of equivalent resistance of a parallel combination, is equal to 1 by R1 plus 1 by R2 plus 1 by R3 up to n values. Now, sir, here every resistance that is given to me is R by N, my friend. R by N, my friend. R by N, my friend. If every resistance is R by N, sir, I think, sir, every resistance is same. Sir, can we take it common? Why not? Sir, N by R can be taken common. 1 plus 1 plus 1. How many? Sir, total is N, sir. So if I add all the 1 that we have over here, what will be the total, my friend? That total will be N itself. Right? So when you add, sir, n numbers, it will be, sum will be n. 1 added n times makes it n. So sir, 1 by Rp will be equal to n by R into n, and Rp will be equal to R by n square. So my dear students, we have the result that, sir, when we cut a wire into n equal parts, making each part's resistance to be R by n and then connecting them in parallel, so the resistance will come out to be R by n square. I hope the concept is clear. Basically, you had to understand one thing, that whenever we are cutting a wire into certain number of equal parts, sir, the number of pieces are divided by that number. That will be the resistance of each part. After that, they can ask you to join it in series, parallel, or whatever they want. I hope the concept is crystal clear to all the students who just went through this. Right? Now, if someone is wondering that, sir, what if they would have connected these in series? My friend, it was already in series. Right? R by N plus R by N plus R by N. The total resistance will come out to be R itself. right? It was already in series. When you cut it out, then you made it as R by N. So R by N, if I connect it N times, so R by N times N, in a series, result will come out to be R. Don't be confused. I hope you guys can absorb this information. Moving on to the third question of the series. We have three resistances, each of 8 ohm. Please mark it out, whatever the information is, are connected to a triangle. The resistance between the two terminals. So, sir, triangle is there, sir. They are saying yes. If I say that a triangle I try to make with three resistors which are 8 ohm each, something like this is what I will get finally. I say yes or no. We will get 8, 8, 8, 3 sides each carrying 8 ohm. Now, they are asking what is the resistance between two terminals. So please always remember, students often ask me that, sir, sometimes they ask me across this point, across that point, sir, how should I be, carrying that information? Please understand. These are the two adjacent ends or terminals. Yes. Try to place a battery across this. Okay, done, sir. Now, my friend, I hope you guys do understand that, sir, a certain amount of current is drawn from the positive terminal of the battery. The current goes from higher potential to lower potential. So if your current goes from higher potential to lower potential, sir, current will start its journey from here. And after reaching this point, sir, it has two options. Let's say some current goes in upward and some current goes in the second wire. Imagine the current in the upward wire is I1 and in the bottom wire it is I2. Obviously, I1 plus I2 must be equal to I, my friend. The current that comes, it further divides into two parts at a junction. Now, sir, I1 goes through this 8, I2 goes through this 8, and my friend, the interesting fact is this I1 will also be passing through this 8. Sir, what are you trying to establish? My dear students, understand one fact. If the current through two resistors or three resistors, whatever number of resistors you have in a circuit, if the current is same through the two resistors, you can always say they are in series. They are in series, right? So that makes me understand, sir, these two resistors, are they in series? Yes. 8 plus 8, RS is equal to R1 plus R2. So I can write it down as 8 plus 8, that is 16 ohm. So that means, sir, I can take this to remove it and add a 16 ohm resistor here. And if you do that, I always say this, redrawing the circuit is an art and you should be the artist. Make sure that when you remove the two resistors from a circuit, sir, I should replace it with the equivalent resistance I got. So, sir, if I remove them, I will get 16 ohm. And this is your 8 ohm. And, sir, battery was across these two terminals, sir, as we considered in the starting. Now, if 16 and 8, you have a look at it, sir, they both are in parallel. If they both are in parallel, because, sir, how do you identify? My friend, their terminals, both the sides are connected to the same terminal, same potential. So please remember, they both are in parallel, and I think by the look of it also, everyone can judge that. So 1 by RP can be written as 1 by 8 plus 1 by 16. And sir, further taking the LCM, I can write this down as 2 plus 1 by 16. So sir, RP will come out equal to as 16 by 3 ohm. Check it out. This is the equivalent resistance. Option D is the correct option. Very, very commonly asked the questions of triangle. Right? So in future also, in the next slides, you will see I have taken 1 or 2 odd questions on the similar lines. So please remember how to identify that two resistors, are they are in series or they are in parallel. And always I say practice makes you perfect. So please make sure that you are practicing enough circuit diagrams so that when you see a question in the exam, you should be confident that I have already done this. And you should understand that what is the path I should follow. You should not take multiple paths and fail again and again. That will take away your confidence in the exam. So please make sure in exam, you should be the commander. And how will you be a commander? By enough practice. Moving on to question number 4. We have in the circuit shown the figure, the reading of the voltmeter V will be. Very good. Sir, they are asking me what is the potential across this particular resistor, because voltmeter is connected across only 100 ohm. So sir, I need the potential difference across 100 ohm. How can we find it out? Let's start, my friend. Forget that voltmeter is there. Voltmeter has nothing to do with our circuit reading. For what we are looking for, we don't need the voltmeter. We will just imagine that there is a voltmeter in the last and our job will be done. How? Check it out. Sir, 100 and 200. Sir, by the look of it, I can tell, sir, the current will come from the positive terminal. It will just pass from here and it will go to the negative terminal. Sir, is the current same through both of them? Yes. If you are wondering, sir, in the last question, the current divided. But why your voltmeter here, when the current comes, why it is not dividing? Arey, my dear students, remember this is an ideal voltmeter. Sir, ideal voltmeter means that the resistance of this is infinite. Infinite resistance. Oh, sir, is that important? Yes. If something has infinite resistance, do you think the current would like to go there? No. That is why we say that what is the resistance of an ideal voltmeter. Remember, the resistance of an ideal voltmeter, my friend, is infinity. No current will ever pass through that. So whatever current passes through 200 will pass from 100. Sir, that makes me understand that they both are in series. And if they are in series, my friend, easy peasy. Sir, we can say 100 plus 200 is how much? 300 ohm. That is the equivalent resistance of the given circuit. Do we already have the voltage? Yes, I see that. I can say that if I know the voltage, I know the resistance of the circuit, Sarji, then we can write down that I is equal to V by R equivalent. Here, voltage is how much? 12. Resistance is how much? 300. Sir, can we cancel it out? 100% yes. You can say that will be 4 by 100, which can further be written as 1 by 25 ampere. But sir, are they asking me to find out the current? No. Question is not about finding the current in the circuit or the current drawn from the battery. The question is, what is the voltage across this, my friend? Sir, voltage across this? Yes. Sir, someone told me that in the series current is same, but voltage is different. Sir, how can we find that out? My friend, if you know that current is IA, so remember the voltage across this, if I say is V1, and across this it is V2. And interesting fact that, sir, V1 plus V2 should always be equal to the voltage of the battery. Because who is the provider? Who is the source of energy? The battery. So voltage drop across this and this, the sum of both of them should be equal to 12 volt. And sir, how will I find that? Everyone, V1 can be written as, sir, I into R1. Sir, what is the current here? Sir, current was 1 by 25 into the resistance 100. Sir, 4 volt is the potential drop across 100 ohm. Potential difference across 100 ohm. And sir, what about V2? Sir, V2 will be IR2, and IR2 means 1 by 25 into 200. My dear students, this will come out to be 8 volt. And did I not tell you that the potential across both of them, the sum of that will be equal to the total potential of the battery. So 4 plus 8, 12 volt. And sir, but question was not about finding the voltage across 200. The question was, what is the potential across 100? Because the voltmeter is connected to the two ends of this 100, my dear student. So sir, V1 is the potential drop. The answer should be 4 volt, option A. The answer should be 4 volt, which is option A. If the question would have been, what is the potential drop across 200, then the answer would have been 8 volt. So I hope if you see a voltmeter, first you should analyze that the two ends of the voltmeter, sir, across which resistor they are connected. Once you find that out, find the current that will pass through it. Once you find the current that is passing through it, V is equal to what? V is equal to IR. Apply the formula, life is good. Moving on to the next question. Sir, a person connects 4 cells in series, but one cell has its terminal reversed. The external resistance is 2 ohm and given to you if each cell has an EMF of 1.5 volt. Everyone, listen to this small concept very carefully. Every one of you know that, sir, battery is basically multiple cells connected together. But now, read the question. A person connects 4 cells. Sir, 4 cells, but one cell has its terminal reversed. Oh, reverse means, see, they connected like this. This is how the 4 were connected. But now, sir, they said one of them got reversed. Oh, if one of them has got reversed, so sir, I think this should look something like this. Everyone, follow it up. I think it should look something like this. Okay. Sir, what will happen? Will it make any difference? 100% yes. 100% yes. So basically what will happen, if you ever have, sir, if there were 4 of them in the same polarity, the way I connected it before, right? The before case, when they all were in the same polarity, in that case, they will support each other. Everyone wants to flow the current in the same direction, right? So in that case, sir, each one of them was 1.5 volt, 1.5 volt, 1.5 volt, 1.5 volt. So the total would have been, it is not, would have been how much? Sir, all of them supporting each other, 1.5 plus 1.5 plus 1.5 plus 1.5. So the total would have been 6 volt. Sir, would have been? Why it is not 6 volt actually? Because they said they are connected in series, but one cell and has its terminal reversed. Now what will happen? Sir, plus 1.5 volt, plus 1.5 volt, plus 1.5 volt, and this one should be minus, sir, because this is trying to oppose this is trying to flow the current in opposite direction. Oh, so sir, it should be taken negative. 100% yes. And you should understand, sir, these 3 are in series supporting each other, 4.5 volts. Sir, how? 1.5 plus 1.5 plus 1.5. So total is how much? 4.5. But this one is reversed, opposite. Sir, minus 1.5 volt. So the resultant of this will be 3 volt. Please remember this concept, that if a battery is reversed, always remember your voltage will be opposing the other cells, right? So in this case, sir, because 3 of the cells were basically in the same direction, we added it up. And sir, why did we subtract this one? Because it was trying to oppose those 3. So 4.5 minus 1.5. So sir, the net voltage that will be provided by this entire setup will be 3 volt. Now they are saying that this is connected to 2 ohm resistor. So sir, end of the day, sir, a resistor is given and you said the outcome of this entire thing, whatever we had, is 3 volt. 3 volt is the voltage, 2 ohm is the resistance. Question is that how much current will be flowing? My dear students, direct formula according to Ohm's law, sir, I is equal to V by R. Sir, what is the voltage? 3. R is how much? 2. 1.5 ampere is the current that will be flowing through this. Option C is the correct option. I hope you guys can figure out that why did sir subtract that 1.5 from that 4.5, because the terminals were reversed by the person who was using it in the circuit. And specifically such questions which are practical based, these are very important from the perspective of 2026 Cbse. So please make sure that every one of you please understand this concept and follow up with some similar questions in the book and all the question banks that you guys already have. Moving on to the next question. An electric iron of heating element of resistance 88 ohm. So resistance is given? Yes. You can say the resistance is R. Done. Voltage is given, sir. This is connected across a voltage of 220 volt. Easy. For 2 hours. Sir, time is also mentioned. Yes. Time is 2 hours. The electric energy spent in unit will be. Sir, unit? Yes. What is the unit they are talking about? My dear students, they are talking about commercial unit. Commercial unit. Yes. Commercial unit of electricity. We in India say that last month, we used 1,000 units. Now, obviously, they don't talk in the units that you guys use. We don't talk in joules because energy's SI unit is what? Joule. But the commercial unit in which the electricity is received by different households in India, we use it as kilowatt hour. Remember this, that sir, the kilowatt hour is the commercial unit of energy. And if you have commercial unit of energy as kilowatt hour, I think we should always go for the same method because sir, they have given me the resistance, they have given me the voltage. So sir, what is the formula? And often people say, sir, which formula should we use? My dear student, have a look at what is given to you. Once you understand that, your life is sorted. You can easily understand that what exactly we need to do. Sir, as far as I remember, sir, power into time is my energy. Right? Power into time is the energy. So we can write down, sir, what is power? Power is V square by R into time. Yes. But sir, when I find the power, sir, which is V square by R, sir, what will be the unit I will get? Sir, because resistance is in SI, sir, voltage is in volt, which is also SI. Sir, 220 into 220 divided by 88. So the result that I will get when I cancel this, let's say you cancel it on 8, this will be 20. This will be, again you can cancel it at 2, 5, 110. Right? From here you will get 550 watt. 550 watt. My dear students, always remember whenever you are talking about commercial units, convert it into kilowatt. Sir, is it difficult? Arey nahi. How? Sir, we can say the power is nothing but 550 divided by 1000. Right? 550 divided by 1000. Right? So sir, here we can say that we will get 0.550 kilowatt. Here we have 0.550 kilowatt. Now what to do with that? We just need to multiply that with the time. Because you got power in kilowatt, substitute this in kilowatt, and this is already given in hours, sir. We can write down 0.55 into 2. Sir, what will I get? I will get 1.1, which is kilowatt hour. Check it out, my dear students. Right? So 1.1, sir, do we have that in the option? 100%, why would we not? Yes. So please remember, whenever they are talking about the commercial units, right? So go for kilowatt first power. Power I will get in watt and then convert it into kilowatt. So divided with 1000, I will get 0.550 kilowatt. And once I have the power in kilowatt, multiply with the time in hour, job is done. Can we proceed to the next question? Similar questions, they can also give you the price of a unit. When you have a price of the unit, let's suppose they say that 1 unit costs 10 rupees. Just multiply that cost. So this many units, 1.1 units. So each unit is 10 rupees, multiply. 11 rupees will be the answer. Right? So please understand how to deal with questions that are based on commercial units. Moving on to the next question, please. Two identical heater wires are first connected in series and then in parallel with a source of electricity. The ratio of heat produced. Easy. Sir, first they are connecting these wires in series. Let's do it. Assumption should be there, my dear students. We should always assume that, sir, if they are saying 2 wires are connected in series, so assume that, sir, both of them has resistance how much? R and R. Okay. And sir, then they are saying that they are connecting them in what? Parallel. if they are connecting them in parallel, sir, across the same source of electricity, so sir, R and R in parallel. Without looking left or right or here and there, my dear students, we should remember, sir, series. Sir, R equivalent will be how much? 2R. Sir, parallel? Yes. Identical resistors, when they are connected across in parallel, sir, just divide by the number. So R parallel will be R by 2. If you want to use the formula 1 by R plus 1 by R, my dear students, you will get 2 by R is equal to 1 by RP. RP will be equal to R by 2. I hope you guys are good and flowing well with this direct result. Moving on. Now voltage is there. So end of the day, sir, when I remove both of them, so this is the voltage. Sir, 2R is connected across it. Yes. Now, sir, same way we have the source V and R by 2 is connected across this. Now, my dear students, come to the question. Question is saying that what is the ratio of heat produced? Obviously, if they are not mentioning the time, so we will assume that time for both of them will be same, right? So, sir, the formula that we should use, again, same confusion, I square R or V square by R. My dear students, finally you see this. Sir, this one is connected across the voltage V. This one is connected across the voltage V. Will the current in both of them will be same? No. Don't make that mistake. It's a sin to do that mistake. Do not believe that I square R, sir, I will be same. Because resistance is different, so that means current will be same. You can substitute the formula and get the results also. Now, moving on, sir, what is the heat in the first case? Sir, heat in the first case will be V square by R into T. Sir, what is the R1 in the first case? I can write it down as V square T by 2R. Okay. Sir, what about the second case? Sir, in the second case, we had V square by R2 into T. Sir, R2 is this second combination I am believing, which will be V square into T by R by 2. Now they are asking the ratio. I hope we are good with this part. Sir, H1 divided by H2, V square T by 2R. Now dividing with this, sir, the denominator will jump to the numerator. Sir, we can write it down as V square T R by 2. Sir, V square T cancelled. Happy news. Now we are left with R by 2 into 2R because the denominator of the numerator will jump to the denominator. Sir, R also got cancelled. 1 by 4 is the result. My dear students, check it out. The ratio of heat, assuming that time is basically same, which they have not mentioned, but we will believe that, right? If it is not given, so we will believe that, sir, the time for both of them will also be same. Resistance was different, so we used, sir, basically V square by R because they both are connected across the same battery, 2R also and your R by 2 also. I hope you understood why I used the formula V square by RT. Why I did not use the formula I square RT? Because, my dear students, current was not the same in both the cases. Voltage was same. So we will use the formula V square by RT. I hope the simple and basic concept of and a question of heat is clear to everyone. Very commonly they will ask you the ratios for heat. Remember, if the currents are same, so then you use I square RT. If the voltages are same, then we use V square by RT because you are looking for the ratio and it will be easily cancelled, right? Moving on to the next one. Now, this is again something I realized that, some of you have not seen similar question before. So please go through it and see what we are trying to do. Here, sir, some meter is given. Yes. Sir, this is milliampere. Whose unit is milliampere? Current. And remember, this is important, my friend. Milliampere. That means, sir, this is measuring the current in milliampere. And this one is voltmeter. Yes. The question is very simple. The value of the resistance of the resistor is. So, my dear students, I think every one of us by now knows the Ohm's law. Sir, V is equal to IR. Yes. Sir, R is equal to V by I. Yes. But, sir, they have not given me directly the current and the voltage. Rather, they have given me these meters, sir. Can we identify how much current these readings are basically shown in this? Everyone, follow up. First question first. What is this each division that you have over here? What is this each division measuring? That should be a good question. See this, 100 is basically this entire 100 is divided into how many parts? Sir, 1, 2, 3, 4, 5. 100 is divided into, sir, 5 parts. My dear students, can I say that each division is measuring how much? 20. 20 what? 20 milliampere. Because, sir, it is written here, sir, this is milliampere. The units in which this is measuring is milliampere. I'll come to that conclusion later, what is the conversion of milli and all. But first, let's read where this needle is. So, sir, 100 to done. Now, you said that each division is measuring how much? 20. So, sir, 120, 140, 160, 180, sir. 180 milliampere is the total current that this meter is trying to indicate here. Always remember, whatever the total reading is there, divide it with the total number of divisions. You will understand that what each division is measuring. This is also called least count, right? I'll not go too much into depth of new terms, but believe on this that, sir, I can easily figure out that if 100 is divided into 5 parts, each of them will be measuring 20 milliampere. And sir, from 100, 1, 2, 3, 4. 4 into 20, 80. 180 is the reading. So current is how much? Sir, 180 milliampere. And now we have come to this part. So let's convert it also. We need everything in SI unit. So sir, but this is not. No. This is milli. I hope everyone remembers this part, that milliampere is equal to 10 to power minus 3 ampere. If you not, please make a box on the top of the paper wherever you are writing and write down, sir, milli can be exchanged with 10 to power minus 3. And micro can be exchanged with 10 to power minus 6. Always remember, doesn't matter it is ampere or charge in coulomb. Millicoulomb, microcoulomb, whenever you have to change micro or milli, replace it with the multiples that you see, 10 to power minus 3 or 10 to power minus 6. Moving on, sir, this was milli, sir. So remember, 180 into 10 to power minus 3 ampere is the current. Don't be scared with these powers. It has nothing much to do with anything. You just have to substitute the values and get the results. Sir, what about this, sir, voltmeter? Now, I would expect you guys to please figure out the value, what this meter is indicating here. Try it out. I'll help you. Sir, 1 is divided, sir, in how many parts? 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. Sir, will it always be in 5 divisions? I am not promising you that. It can be 5 also, it can be 10 also. But we are smart enough to understand in the question whenever I see a meter that, sir, what exactly is the number of divisions? 1 divided into 5 parts. Oh, sir, each division will give me what? 0.2. Sir, 0.2 what? Check the unit. Volt. And 0.2 what? 0.2 volt. Sir, I know now every division is 0.2 volt. So if you start from here, 1, sir, obviously it is ahead of 1. 1, 1.2, 1.4, 1.6, 1.8. 1.8. So, sir, voltmeter's reading is how much? 1.8 volt. If we got current, sir, R to, sir, is not a big deal. I can write down according to the Ohm's law, sir, V by I is the resistance. Sir, voltage is 1.8 divided by 180 into 10 to power minus 3. Now, many students I have seen, they mess around with the mathematics. Physics is not tough. Sometimes mathematics is, right? But please be very careful with the calculation. Now, when you have 1.8, now some students have a habit of multiplying and dividing with 10. Okay. Sir, what will I get? I will get 18 by 1800. Sir, how? Another 0? This 10 got multiplied. And sir, what about this one? Bring it to the numerator, 10 to power 3. Sir, this will be how much? 1 by 100. Oh, sir, what about this one? bring it up again. So you will get 10 to power 3. This was 100, can be written as 10 to power 2. If I bring it up, sir, it will become 10 to power minus 2. Sir, base is same, power is different. Base is same and power is different. What should we do? Sir, add the powers. Plus 3 minus 2. The answer that you will get is 10 ohm. Let's look into the options. Option D is the correct option. Option D is the correct option. I hope all of you learned that how to find out the least count, the division, one division, sir, how much it calculates. If you know that, my dear students, reading a ammeter and voltmeter is not a task. Another important point that you must have noticed, that sir, this is also important. That sir, what unit is the current basically measured in? What unit the voltage is measured in? So please be very careful with the given meters and their units. Right? And once we knew the voltage and current, then I don't believe, using Ohm's law is rocket science for us. Moving on to the next question. Now, another interesting question. Study the IV graph for 4 conductors A, B, C, D having resistance RA, RB, RC, RD. Easy. Sir, the answer the following question. Now, always I tell my students, and I believe all of you must have heard this story from your teachers, right? That sir, whenever we have IV graph, rather than digging into what is the slope and all, right? Sir, if it is IV, sir told the resistance will be, the slope will be 1 by R. Sir, when it is VI, the teacher told slope will be R. Don't be confused. Directly remember that, sir, the one that is closest to voltage, sir, that will have the maximum resistance. Meaning, sir, here RA will be maximum, RB will be next, RC will be next, and minimum will be your RD. Remember this, right? That, sir, at a certain particular voltage, how do you just justify that? I can justify that, sir, at a particular voltage, I see that they have different currents. Right? And if you see the current at that voltage in A is a minimum, sir. Minimum current is at A, and then B, then more at C, then more at D. Sir, minimum current. Why the current is minimum, sir, at that voltage for A? Because the resistance of A must be bigger. So remember this, my dear students, that whichever you see is closer to the voltage axis does not matter. Sir, if the voltage is given on x-axis or y-axis, just mark it out that, sir, the one that is closer to voltage axis, that resistance will be bigger. So RA is greater than RB, is greater than RC, is greater than RD. I think the 5th question that you have as a MCQ, that we can easily mark it out. Right? Beautiful case-based study question that can be found out of such examples. Right? Let's read the other questions and see what they're talking about. Which one of the is the best conductor? Sir, conductor, best conductor, sir. Best conductor is the one that has the least resistance. Because resistance is what? The opposition. Sir, conductor, beautiful conductor is what? Beautiful conductor is the one that does not stop and says electrons pass through me. Right? That is called your best conductor. Sir, least resistance, by looking at the order, sir, I can say that D is the one that has the least resistance and it will be the best conductor. And if they ask which one out of the 3 is most insulating or worst conductor, A, because the resistance for that is maximum. Moving on to the next one. If all the conductors are of same length and same material, length is same. So the material, sir, the factor that encounters and basically counts for the material is resistivity or specific resistance, some people call it. Right? So that means, sir, they are saying all of these A, B, C, D, their length is same, their resistivity is same. Which one of them will be thickest? Area. So, sir, if I see R is equal to rho L by A. Now, when I compare them, sir, rho L, I will not even look at, sir. Why? Because it is same. If it is same, do you need to look and compare them? Not at all. That is, quantity is same for all the 4. So, resistance, sir, and area we need to focus on. Yes. My dear students, more the resistance, lesser will be the area. Lesser the resistance, more will be the area. Inverse relation, right? Inverse relation. More the hard work, more are the chances for success. Direct relation. More the wastage of time, lesser is the chance for success. Inverse relation. Remember that. Remember that. Sir, here the inverse relation is there. So that means, sir, the one that has the maximum resistance will have the least area, and the one that has least resistance will have the maximum area. So my dear students, what are they asking? Which one of them is thickest? Sir, thickest means, sir, biggest area. Yes, biggest area. Sir, least resistance. Who is having the least resistance, my dear students? D. So you can say that, sir, D is the one that will have the thickest area. Least resistance, maximum area, because the relation is inverse, my dear students. I hope this small little example is very clear to all of you who are studying right now. If all the conductors have the same thickness, oh, now area is same, sir. Yes. And the same material, resistivity is same, sir. Which of them is the longest? As I said, R is equal to rho L by A. Now you don't have to look at the material, resistivity or the area, because that is given same. So resistance is directly proportional to what? Length. The one that has the maximum resistance will have the maximum length. Direct relation. Right? So sir, direct relation means, sir, the one that has the maximum resistance, which is A, will be the longest. My dear students, the answer will be option A. Right? That out of the 4, you have to write the statement, sir, the longest wire will be A wire. Right? And what is the reason? That, sir, because the resistance of that was maximum, and the length will also be maximum, because the direct relation is what they hold with each other. And specifically when specific resistance and area are given to be the same. Moving on to the next one. If the dimensions of all the conductors are identical, oh, dimensions, sir, area and length also. Yes, area and length both are same, but their materials are different. Oh, material, resistivity, sir, resistivity is what they are talking about. Yes, if you identify that in the first reading, I'm telling you, you are on the right path. Believe me on that. Right? Sir, resistivity is basically different. Which one would you use as a resistance? Now, obviously, if you want to use something as a resistance wire, sir, first of all, I should understand that more resistivity basically means more resistance. Right? Now, I want to use something as the resistance wire. So, I want more resistance, sir. Which one is having the most resistance out of this? A. If I have to use something as a resistance wire, I would like to use A that had the maximum resistance. And sir, what about the second one? Connecting wire. Now, when you want to use something as a connecting wire to connect the multiple appliances with each other, you want that, sir, they should not use much energy, sir. Their resistance should be least. So please remember, the one with the least resistance for the B, I should use that one, which is your D wire. I hope this one question gives you clarity that how a question can be framed specifically from the factors on which the resistance depends. So everyone, make sure that write down the points that you, bullet points that you learned from this, and how a question got framed through the graph, right? Through the graph. And how to find out that which one is more resistive and which one is having less resistance. I hope you guys can easily figure that out. The one that will be closer to the voltage, so that will be having more resistance. Moving on to the next question. Now, calculate the effective resistance. As I mentioned, I took some of the questions which are basically circuit questions, because many of the students are struggling with that. See, you should have the I. Always remember, they are asking between the points PQ. So always remember, sir, if they are asking across the point PQ, place a battery to make your life much easier, so that evidently I can see by looking at the circuit that which of the two are sir pakka pakka in series, sir other two which of them are in parallel, pakka pakka parallel. That you can easily identify if you have a battery already placed intact. Now 7 and 3 series. Sir, why? Whatever current will come, it will pass from this. Say yes or no? Yes. Is there any other path? Is there a junction in between? No, 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 no. No junction. Current will smoothly pass. Sir, what about this one? 6 and 4, again series. Whatever current will pass from this side, sir, that will come through Q. So that means these two are in series. Yes. First do one thing. Take baby steps. Don't try to grab everything in one go. Bite by bite. Not like taking the play. We don't do that. One by one. Sir, 7 plus 3, 10 ohm. Sir, 6 plus 4, 10 ohm. Done. Sir, now what? Now, sir, I can say that basically P, one of them 10 connected. In the middle, sir, some 1 was there. Yes. And sir, then we have the third one, which is again 10 ohm. Now, this is what you are connected with the battery. Now, I think now it's not a difficult task for everyone to identify. Sir, these three are in parallel. If these three are in parallel, then I can directly use the formula that 1 by Rp is equal to 1 by 10 plus 1 by 10 plus 1 by 1. Take the LCM 10. Sir, we can get from here that 1 by Rp will be equal to 1 plus 1 plus 10. That will be, my friend, 12. Right? Divided by 10, cancel it out, 6, 5. Rp is coming out as 5 by 6 ohm. Check it out. 5 by 6 ohm is the equivalent resistance across your PQ points. Right? Question would have been completely different if they would have told you find the resistance across, let's suppose, BQ. If you want to try, take it as a homework, right? Draw the same circuit and try to mark the BQ point as the positive terminal connected to the battery and negative terminal Q connected to the negative terminal of the battery. Try that question and see, will the results change? And if you will have doubts to that, please make sure you mention it in the comments. We'll come back with the solution to that as well.